In relatively humid areas, the water table tends to be shallow, especially near streams. In the soil area above the water table, yet below the surface, there is a finite void space that can be occupied by infiltrating water. This volume of empty pore space is also called the soil moisture deficit and may be thought of as a bucket that can be filled with water. Rainfall that infiltrates fills the soil moisture deficit until the soil is completely saturated. The bucket overflows and no further water can infiltrate. All rain that falls on the surface following saturation runs off and is called saturation excess runoff. The process of the soil profile filling up with water is called saturation from below.
Because the depth to the water table, soil moisture deficit, or bucket size, varies with the topography, the amount of water required to trigger saturation excess overland flow also varies. Variable source area refers to the saturated area contributing to saturation excess, which can vary at any point in time. The contour map on the right shows the expansion of the saturated area in valley floors and areas with convergent topography. This variation of saturated area occurs within a storm and also at seasonal timescales. During the wet season, some area may be saturated before the storm starts and will immediately contribute to runoff once surface water input starts. Notice also that at the same time as the saturation excess process occurs, return flow across the saturated surface and subsurface storm flow are also occurring. The subsurface storm flow is driven by the gradient between the water table level increase near the stream due to the rainstorm and the stream surface water level. In this situation, saturation excess overland flow and return flow both add to runoff.